Mr. Z here, and I'm going to talk to you more about residuals and residual plots. If you remember from our previous lessons, a residual is the difference between an observed value of the response variable and the value predicted by the regression line. Residual is actual y minus predicted y, or y minus y hat, and we use the acronym residual RAP to help us remember that. Okay, so to walk us through or help us through the lesson, we have a data table with age at first word and Giselle score of 21 children. Now, this is their age in months, and this is their score, and we're determining to see if there's a relationship. So, as with any data, we want to plug in our calculator and create a scatter plot, calculate the least squared regression line, and plot the line on the graph. So we're going to kind of do that as a quick review. These numbers here are irrelevant as far as the data is concerned. It's just telling you which child it is. So what I've done is I've already put the numbers in list 1 and list 2. If you need to pause the video to go ahead and do that, please do so. But I will proceed. After you type in the data list 1, list 2, stat over to calc, down to linreg ax plus b. Be sure to tell it list 1, comma list 2, or whatever list you have the data typed into. Hit enter, and I get my least squared regression line. Okay, remember a is the slope, b is the y-intercept, r squared is the coefficient of determination, and r is the correlation. So this has a moderately weak correlation, negative 0.6403, 40.997, or let's call that 41% of the variation in score can be explained by the least squared regression line. We've got a slope of negative 1.13, which says that as each one increase in age, month, their score goes down by negative 1.13, and the y-intercept of 109.8, we're basically saying a child of 0 months would have a score of 109.87, which again is not really relevant to this question. Okay, so quick review, second stat plot. We go down, we make sure it's a scatter plot, list 1, list 2, and we zoom 9, and there's our scatter plot. Now notice how I've got this little random line in here. Okay, if I go to my y equals, I've got some other line in here from a previous problem. I clear that line. Now what I'm going to do is I'm going to type in, okay, so there's the linear regression, there's the scatter plot. I'm going to type in this formula right here, which is my least squared regression line, negative 1.127x plus 109.8738. And now, when I zoom 9, I get the least squared regression line. Okay, so that's how to plot it in your calculator. Just type it into your y equals. Go back to algebra 2. Okay, now, use the least squared regression line to predict the score of a child who first spoke at 15 months. Okay, so basically I'm going to use this equation here to determine the predicted score of a person who first spoke at 15 months, at age 15 months. Okay, so here's the math for that. I'm basically going to take 15, which is my age, which is an x value. It's going to go in for x. I'm going to multiply this through and add, and I get 92.97. So that's according to the line. Okay, if a little quick trick, if I go to second calc value and I type in 15 for x, it's going to give me 92.97 and put that right on the line. So there's the predicted value. Now you can see right here, okay, the child's actually score was 95, a little bit above that. Okay, so the residual, observed y minus predicted, or actual y minus predicted, would be 95, which was the child's actual score, minus the predicted, and I get 2.03. Okay, so that's each residual, or that's one residual. Now, each one of these points has a residual, okay? The distance from here to the line, basically, from the actual to the predicted, actual to predicted. Remember that dots below the line will have negative residuals, and dots above the line will have positive residuals. Okay, so do we want to have to do this for every predicted point? Probably not. Guess what? Your calculator will figure them all out. So I'll walk you through how to do it on your calculator. Now, to access the list of residuals, okay, so once I do this linear regression, when I run the linear regression on two data sets, it automatically calculates all the residuals. Okay, so if I go to second, stat, and go down to number 7, I get a list of the residuals. Okay, now this is just a scan list. This doesn't really help me because I don't know which ones go with which points, but it actually lists all the residuals. Now, a key point is that the sum of those residuals is always 0. We're really, really close. Okay, so now I'm going to show you how to do what's called a residual plot. Okay, so basically what I'm going to do is I'm going to go into my y equals and my second stat plot, and I'm going to go down to my y list. And instead of using list 2, I'm going to plot the residuals. So second stat, I go down to 7, resid, okay, and then I hit zoom 9, okay. And what's that's going to do is that's going to create more or less a sideways graph, and it's a residual plot. So if I hit trace, each point gives its x value, 15, and the residual, which that's the residual of the very first one that we calculated, 2.03. So as I scroll through here, I get each point the x value, so 26. Again, that was the, if I go back, that was the second child, 26, had a score of 71. The residual was negative 9.5. Okay? An x of 10 had a residual of negative 15.6. So their actual score, okay, their actual score was less than what they should have, not what they should have been, but what our model predicts. This is our basically least squared regression line. Okay, so we get this residual plot. Now, the last thing we're going to talk about is how to interpret the residual plots. So again, you may need to pause this to copy these down, but a residual plot is a scatter plot of the regression residuals against the explanatory variable. So x and the residuals. The residual plot helps us assess the fit of a regression line. Okay, so it basically determines if a linear model is appropriate. This is a good residual plot. A linear regression line is most appropriate when the residuals are scattered with no pattern. Here you've got some residuals up and down and below line. They're scattered about the line. So this says that the line, if this is my LSRL, that this is a good model for the data. A line, a linear model, is good for the data because there's no pattern. Okay, now if you get something that shows a curved pattern, this shows that the relationship is clearly not linear. A straight line is not a good summary for such data. So if I look at a residual plot and I've got this curved pattern, okay, basically this line here, my least squared regression line, does not model this data well. I mean, if you can think about it, these dots are going to keep dropping off, and so my least squared regression line is going to kind of get worse and worse as a predictor. Okay? Any other sort of pattern that I see, may it be increasing or decreasing spread about the line. So if this data is getting more and more spread out, this line is not a good model for the data, and we use the residual plot to figure that out.